Hold on, let's wait for some adjustments. Okay, we can start. Hello everyone. Let's start the session, and just as I promised, let's start with the conflicts. Just changes first. Then I will show how the conflict may look like, and just what to do with it. Let's talk it as well. So imagine we have the same, just to start we have, this is the master branch. As you can see, there's no class created under our main package. If we thank you very much. Thank you. Just share the screen. Okay, so here is the screen. Again, as you can see, we have the project. It is connected to Git repository. Then it has, so we are on the master branch. Then we can switch to the, so I don't have my branch in the branch. We can see that there's something inside. Let's make it this way. Then again, remember to commit, because we cannot merge or pull between the branches if we don't commit the changes. So the commit reflects the changes on the local repository again, and if we push it reflects the changes on the remote repository. Let's push the changes to the remote repository. And again, let's switch back to the master branch. So imagine we want to pull the changes from maybe first let's create the class. Just the same class as we have in the front branch. There's the method, and let's That's something else. Something like that. And yeah, imagine now if we pull. Let's connect. And now let's pull the changes. Sorry. From here, but from different branch. Just like let's think for a second. I want to pull the changes from different branch. This is the one I want to find. Yes, and if I try to pull the changes, we can see that there's different code and we have the conflict. And yeah, this one this pattern represents us that this needs to be solved in some way. So this is the conflict, and this is not really good if you have this, because it means that something is not really correct from the organizational point of view or the planning point of view. Because normally 2 or more people should not work on the same files. So here we can obviously solve it, like we can merge the changes if we want this way. And you'll still see that we have the conflict. It points with this red sign that there's still the conflict, and we need to commit the changes to solve this conflict. And now we can see that no conflicts are there. Also be careful and trying to escape the conflicts. Yes, maybe let's start with some questions you wrote to me yesterday. I think that there was only the questions from Svetlana. So maybe there are some useful questions. So maybe let me maybe just share them this way. Or maybe I can. Is it fine, Svetlana, if I just paste these questions to the main chat so I can follow the topic? Yeah. Okay, so here are the questions, and let's go one by one. So the first question: difference between remote add and clone. Remote add means that we set up the remote repository. Like in this case, when we are on a local Git repository, then we set up, we add remote, so it means that we actually add entry under the remote. If we do, if we can actually, we have 2 options. We can do it from the console, like with Git bash, or we can do it with set up here on Git tool and Eclipse. And basically remote add means that we add something under the key remote. It actually means remote. The key, the components separated by. Maybe I never tried it to do it from here, but in fact that's quite the same if we do it from here. We add remote branch and not branch but remote key, and we add origin. And remote add means that we add something to under the T remote. And remote add means we add something under remote. And as you remember, we had remote origin, and then we add the URL. So now we can have URL, and the clone command means that we just clone our and then we can just replicate it quickly. It just means that it doesn't really matter where we do it. So if we do git bash here, we can bucket and check one of the repositories we have. Here we can copy the command clone, then the name of the repository, the link, the URL of the repository, and in git bash we can paste this command, execute, and this will create the clone of our remote repository. So it just basically means that we copy all the files from our remote repository to our local place, and even more, we don't need to initialize the repository. So that's what's the difference. And they said if we join existing, because it's not really correct. If we join it, if we copy the existing repository, because again, as I said last time, the local Git repository and the remote repository is not the same. These are two different file systems. Let's call them. The common things they have is that we can multi changes from one place to another. So if we delete something, we send the deletion flag to the file on the remote repository. That will delete and then we push the changes. Then that will delete the file from the remote repository. If we add a new file, that will add the file to the repository, and change if we do the changes in the file. So these are two different repositories, but they are quite linked. That's about remote and clone. The second question: what's the difference between fetch and pull? This is quite an interesting question, and this is a little bit related to the things we done on Wednesday when we are talking about the remote branches. So you remember we have two types of branches. We have local branches and we have remote branches. And what does it mean? It means that if I think is it the same? Let me check. So that's task life, and this is not test1, where is it? No, that's not test1. Okay, this one. Just need to remember which one it's to. Yeah, this is test1. Does it have... Okay, as you can see, we are missing some remote repositories here. And what's the difference between pull and fetch? As you remember from the file here, from the presentation, as it is shown here, git fetch is basically, as we have commit, it means that so that's the pre-step to push the changes. So that's one small step, and then push, that's another small step. If we have git pull, it means that regardless what we have here, we just fetch everything inside our local repository. And just to make it more clear, let's plot, this one, what we can do, we can try to fetch something. Remote, we use fetch from, yes, and that's basically what we did last time. Here we can see, I think I showed you last time this. We have remote branches, and what we can just do, we can import the remote branch to our local repository, and it shouldn't, that should not affect the changes, but we can see that you can see our local branches stay as is, but the remote branches appear here. So it basically means the first step. If we just simply pull something, it will pull all the changes directly to our local branches. So if we do pull, that will directly pull all the changes from the one more time. Remote, as you remember, if we start from the beginning, maybe let's do it one more time. As you can see, we have two Git repositories, local Git repositories. Yes, this one and this one, and both of them are connected to the same remote repository. And test live, and this one is connected to test live as well. And so both of them are connected to the same repository, and at the moment they are synchronized. They are synchronized except this one. Okay, that was merged, but they are synchronized. And if we add a new branch here, let's create a new branch. Switch to new branch. Just test. Let's more code here. Then commit and push. Yes, no. And yeah, now we can see new remote branches added to this Git repository. Yes, that's the one we just created here. Yeah? So once we create, we push the changes, then a new branch is created on the remote repository as well, right? So that's how it looks, but here we still don't see it. Yeah, so there is no this branch which was created from this repository. However, we can see that it actually, these repositories are connected to the same remote repository. In real life, of course, you won't have the same connection to the repositories from your local projects, but I'm just showing it that you imagine that this local repository belongs to one team member, and imagine that this local repository is located on another team member's computer. Yeah? So I'm just showing this to you, so you imagine that this is person A from the project, and this is person B from the project, and they both have the same remote repository. Yeah, okay, in the bucket, yeah, Git repository, but they both have their local repositories. Yeah? So currently I'm showing how to do the synchronization. Yeah? And yes, and if we go to this one, we can still see that there are no changes here, of course, because we haven't pulled or fetched anything. And if we request for fetching, yes, fetch from, and yeah, new branch is now here. Yes, so we can define the web destination, and it's something like this. Then finish, and we can see that we have new branch here. Nothing is actually changed here, but we have a new remote branch here. Yeah, here it is, and so it is available for us. So now we have a new branch. Yeah, now we have a new branch which was created in this repository, then placed on the remote repository, and now we fetched this branch here, right? So yeah, is it clear? Yeah. So at this point. Yeah. So is it clear at this point? Yes, very good. And yeah, now we can see that still nothing is changed, just a new remote branch. And of course, now from here we can create the same local branch. If we double click on it, check out the new local branch, we create a new local branch, then we have local branch here, and all the changes are here, but we can still move between the branches and have different changes there. Yeah, that's how the fetch looks like. Let's take the opposite example, how the pull looks like. So now we have the branches, and let's create another branch. So now from this repository, and we'll try to pull the changes from the opposite repository. So maybe create a new branch to pull. Finish. Now we have a new branch. Let's add some more code. Just something like that. Then let's commit and push changes to remote repository. So again, nothing will automatically be replicated in our opposite repository. At this point, and if we go here, something. If we go here, you can see we still have previous changes, but if we do the pull, and it is new branch pull. Yeah, we can now see that it is, despite the fact that it's not here, we can find it here, and try to pull. Then we pull, and we have the conflict now. Have the conflict because we have different line of code. Even more now we have the conflict. So it just means that we just forcefully merged the changes from the branch we provide here. It doesn't really matter. We provide the branch here. That's the remote branch, the branch which is located on the remote repository. Here. That's the branch located here, and the changes which are located in the remote repository. And here we provide the reference to the branch, and we just pull the changes, we merge the changes. Not only merge, as we can see there are different options here. We can merge, we can rebase, maybe we can just stick with merge. So that's the difference. Fetch is just like we add a new repository, remote branch which can be reused as another branch. If we after that also this branch will be here. That's maybe one more thing. If we so now we have this branch here. If we go to this repository, and let's see how our new branch which branch am I here? I'm on new branch. Okay, new branch, and if we go from here, we can see that which already exists. We need to check out. you can see that should have different. Yeah, this one. Sorry. And this one still has the previous changes. And let's commit. There was a commit message here. And now if we try to fetch, I remember we had different code here and different code here. Yeah, so here we have, this is the same file. The branches are the same. The remote branches are the same, but the local branches are, of course, different. And if we try to fetch the changes now, fetch from, yes, right, the same branch, finish. Left to fetch everything. Okay, it shows up to date. Yeah, so in this case it cannot be updated this way. So yeah, basically we just can add the new branch here, and we can create a new test branch, not test me, but copy. So now we have the copy. Oh, sorry, just accidentally typed. And yeah, in this case, as you can see, it is still not updated. But what we can do, we can create a new remote branch here. So if we copy, finish, okay, I pushed the changes. I think I have not pushed the changes, that's why. Yes, I think I missed pushing the changes, sorry. That's why I have such strange situation here. Yes, now push the changes. And I hope that now the remote branch should just copy it the second time. Okay, it's still does have am I on the right? Okay, yeah. So now it has new branch here. If we go here, yes, it just adds new remote branch here, but yeah, we still need to. Okay, I think I have pushed changes from. Let's check. Maybe, yes, maybe I still missed pushing the changes here. And so that still should be the same. Maybe let's delete these branches. Just not confuse ourselves. So delete this branch again. Okay, and if I get it from from the remote branch, changes still are not extract. Check out. Okay, that's still. Yes, I'm not tracked. It means that they are not on the stage changes. So if you change them, then changes won't be. Okay, it's up. Okay. Changes will not be replicated. Oh, okay. Just then. Yeah, if not tracked, the changes are not replicated. Okay, maybe, yeah, just one more time. Remote, fetch, yes. New branch, finish. Okay, now the changes are here. Now let's delete this copy branch and let's check this new branch again. Okay, check our new local branch. Then we have the copy. Then we have copy. And yes, finally I got them. Yeah, so I just, sorry, a little bit messed with the commits and pushing. So again, what's the idea? I think you missed the point, most of you at the moment, because of some chaotic moves here. So just a small summary of what we just what happened. We have the branch. Maybe again, let's do it from here, and at the moment I will push all the changes. So we have the changes in our local branch, and then we change, we commit, and we push the changes. So once we push the changes will be pushed to the remote repository, and will also be pushed to the remote branch. So now the changes will be here as well. So now we are on the new branch copy, and I think I pushed pushed it to new branch. It doesn't really matter how many branches we have here, we can push them to the same branch on remote repository. So now the changes are on new branch, as we pushed, so we just already done it. We pushed the changes on the new branch, on the remote, and now the changes are under this branch, and it should also, now we can go to different, not to different, but to the opposite repository, and so here's the branch, but at the moment this branch is not updated yet. If we do the fetch, we fetch from this new branch. Now we just push the changes, so I'm gonna finish fetching. Some reasons, again. So I finish fetching. Sorry, open this repository again. I'm a little bit mixing some things up. Yeah, so this is our original repository. Yeah, this is our original repository, and that's our repository we want, and that's the opposite repository. This one is the opposite repository, and here is new branch, but at the moment it is not updated. To update it, we need to fetch changes. So we fetch the changes, and we can see that there's a difference. We just got the comment. Then from here, just maybe let's check out and let's delete the branch. Yes, let's delete the branch, and at the moment I can create a new branch from the one we just fetched from the remote repository, and we can see that all the changes are here. Is it clear how it works now? Svetlana and others. Just maybe something is missed. It was a little bit fast, I agree, but if it's still not clear, I will just try to write the schema for this. It's okay how those, but clear, what's the difference? Yeah, maybe just a small schema. So again, we have our remote repository, so that's located somewhere remotely, like Bitbucket, and then we have two local repositories. Yeah, in normal case, these are two different computers, and so we have the team. One team member works on one computer, so different team member works on different computer, and both of participants, both of team members have their local Git repositories. Yeah. So maybe let's just do so. And yeah, this is local repository. Yeah. So there's one local Git repository and another local Git repository. And then of course both of them are connected to the remote repository. Yes. And yes, in each local repositories there are two types of branches. Yeah. So there are the branches here, like one branch, then another, and there's another branch, and so on and so on. And so these branches are remote branches, yeah, and they are stored remotely. Of course, nothing is replicated automatically, yeah. And in our local repositories, there are also two there are also two types of branches. So there are local branches and there are remote branches. Yeah, so we do the changes in the local branches, then you push the changes, and then you commit the changes, and you push the changes. So at this point everything will be up to date on this. So again, you have just one, imagine there's one branch here and one branch linked here. You do the changes, you push them to this remote branch. Yeah? So now I push the changes, and the changes are on this branch, for example, and this branch is also here. The same remote branch is here, but the difference is that this branch at this point, when we just push the changes from this computer from this repository, local Git repository to our remote repository, at this point of view, the branch, well, there are two possible cases. The branch may be here, and the branch may not be here. Yeah, just in case this is new branch. So, for example, this person created this branch, created a new branch, push it to the remote, then in remote you'll see a new branch. Here, the branch will not be here. Yeah? If this is the new branch. Yeah, at this point it will be as is. If this is the existing branch, so the branch will be here, here and here, but here you won't see any changes. The changes won't be here at this point. And when you do the fetch, when you fetch from this branch here, the changes will be synchronized, and this remote branch will have, we do the fetch. Yeah. We do the fetch. Then all the changes are replicated to this remote branch. But again, remember that this branch is not updated in on the list of local branches. And the option is that we can merge the changes with the local branch, or we can create a new local branch with the changes from here. And yes, when we merge these changes, we can simply get these changes done on the local repository or local branch. Why we need fetch, not pull? That's the really good question, and the answer is that we need safety. We need safety, and if we do it using the fetch, it means that that we can, as I just done, I created the copy branch. So it means that before we merge our changes, before we do the merge of our changes, we can create a copy to check, to basically check these changes. Yeah. So this is the way how we can check the changes before we do the merge. Yeah. So that's the idea of fetching. If we do the pull, then we skip this and everything. Skip this step and everything goes here. Yes, Marita, it's better to do fetch to actually check how everything works for you. Yes. But again, if you just need to, if you are sure that everything is fine, you can easily use pull. Why we need to merge local and remote branches in the Java file. remote branch. And the question from Sandra: why we need to merge? I try to understand. Why need to merge vocal and remote branches? Because remote branches will always be here. Remote branches just mean that we represent them. Remote branches represent the branches from the remote repository. Local branches are the branches which represent the changes done locally. So this is the main difference. You may have as much branches as you want in your local, as much local branches as you want. Yeah, like you can create thousands. Yeah, you create thousands of local branches here, but you may avoid them pushing to remote. It is just like you create one branch. For example, 5 branches. You create your local 5 branches, then you do different changes in all of them, then you merge these changes, merge them into one branch, delete all these previous branches, and push them into remote repository. Then at the end you will have only one branch pushed to the remote repository. Yeah. Why it is needed? Again, as an option, you may have like 5 different tasks, and you want to. Maybe I cannot really show you the exact example, but I think you can understand the concept that if you have, for example, 5 different tasks, yeah, you just don't want to mess the development of these 5 tasks. Yeah, you can just simply work in 5 different branches. I think you may understand why this may be needed. Yeah. For example, there can be 5 tasks. One task is a hard task, which needs some testing, some thinking, yeah, some complicated stuff to be done. So this task may be put in one branch. And you have a simple task which you can easily create and keep the changes in one branch. And in this case, in theory, you just need to push the changes together. Yeah, so that's the requirement maybe. And in this case, you can split the task in different branches, and at the end, you can merge the changes from 2 different branches and push them to remote repository. Remote branch to a new branch, merge them into a new branch, and you can put this new branch into the remote repository. So that's the idea. Okay, I hope it's more clear now. Let's have 10 minutes break and we'll continue after that. Okay, yeah, you should hear me now. Let's move on. So yeah, that's about the second question. And yeah, then the third one. What is origin? Origin, that's just the place where the remote repository is stored. Yeah. So yeah, if we check properties, we can see that that's the place. Yeah. Where the remote repository is stored. I'm not sure if with these two, I think we don't really need them. It's fine if we just have origin. So that's the place which yeah, in normal, yeah, that's again, that's remote Git repository, because in fact we can have not only Git bucket but different repositories. Like we'll have them in this presentation about version control. There are also different Git remote repositories. Yeah, in our case we just use Git bucket, but again there may be other repositories as well. Okay, that's about the third question. On the fourth one, what is working tree? No, that's not the branches. The working tree is actually the tree of files. Yeah. Maybe if we just type it, working tree. You said working tree, yeah. Yeah, working tree in Git, yeah, that's just it's just a set of files, yeah. The directory, the set of files, that was the okay, I think there was some good picture of this, but not here. Okay, I think this one. So this basically the working tree represents the tree of files. Yeah. This is the working tree. So we have top, then we go to the bottom. It can be in Git, it can be locally as well. It's just the tree of files. And git ignore is needed to not just push all the files, to not stage all the files from the repository, just those which are changed. To ignore some files we don't need to consider in our changes. Just to not push everything from the repository to repository every time. Yeah, that's why we need git ignore. In most cases, this is just as default one we created, and we don't really touch it. Honestly. Okay, that's about Stephanie's questions. Hope that it's more clear now. Okay, then let's maybe finish with the presentation. And so this is, again, the schema. In my opinion, this is quite good schema to understand how the Git operations work and all the stages, all the steps are shown quite well here. I think we've gone through the basic comments here. Yeah, about the branches. The comments are shown here. We can simply do it in Git tool. So that we can create the branches. We can check out the branches, means that we just switch between the branches. And then we can merge the branches. So nothing really special, just seeing them, these things already. So I'm dealing with the conflicts. Here's some explanations about how to deal with the conflicts. Normally we should not, as I said, normally we should not have the conflicts, as it stands here. Yeah, but in case we have, basically when the conflicts can happen if we are trying to change the same file. Different developers try to change the same file in the same branch, of course, parallelly, or in different formatting to the file. In this case, we may have different content of the file, which will trigger us the conflict. And you've seen already today that shows all these brackets and it's complaining that we have conflict. The same file is changed by several persons in different branches. Somebody has to merge branches. Again, that's quite the same. Again, the idea is we merge changes and we have the conflict in merging. And don't allow it to happen. Normally we should not allow this to happen. So how to deal with it? Do file dividing. Yes, as I said, it's normally we should not allow to change the same file, different developers to change the same file. Also, it may happen that you have your own different branches, then you try to merge the changes and you get the conflict. So just also try to avoid it. If you have different branches, then try to not have the same files in different branches. I think that's pretty clear. How that if we divide the files, it's not possible to get the conflict. Time dividing, of course, if you still need to work with the same file, then just make it in the way that the work is split correctly on the same file. Sequentially change them person by person. And use the same formatting rules, don't change the same places of the file. And then there are some comparison and merging tools. We want to talk about them. I can use file comparisons, but we maybe want to do it in our case. There are simple tricks. If you just to avoid the conflicts, you can stash the changes, then pull the changes, then get changes from stash again back. In this case, we may still have the conflict, but it won't be as crucial as if you just pull the changes without conflicts, or we just push the changes without any stashing. And also that was a kind of we just done here. If we create new branch, so that's also as an option, as I said here, before we merge the changes, I create a new local branch. Then I check what are the changes there, and only after that I merge the changes. So just double check, copy, do the backup, and move on. So merging problems, you will see those symbols if you have the comfort. But there's also, it's possible to configure these merge tools. Graphical tools we won't do it, but because we'll need some additional installations. For those who use Linux, it's easy. You just use these commands, and I think you should be able to install everything. For those who use Windows or Mac OS, that may be a little bit more complicated. That's about it, but we won't do some more installations. That's just for your information, but this may be also configured. And this is one small joke about Git. So when one person presents Git to the colleagues, this is Git. It tracks collaborative work of projects to a useful distributed graphic theory pre-model. And they ask how do you use it, and the developer just says, no idea, I just memorize all these commands and add them to sync up. If there are any errors, then just save the project elsewhere, delete the project, and download a fresh copy. I agree that, so this, so again, if you, it shows that if you have some complicities with Git, don't worry, it usually may happen for all the developers. Just again, try to back up the changes, then it's fine to delete it and create your project for thousands of times. If the copy is located on the remote repository, you are safe. You just have everything, and you can access this copy every time you want. So there are no worries. And of course, you can do the local backups. The local backups are always welcome as well. That's about it. If conflicts appear, try to again do more backups. Then compare copies with different comparison tools. I think in Eclipse you can also compare them. If you if you go to file history, you can always see the comparison between two files, and if you just use history, you can always see the comparison between two files. You can also switch between the branches and check the changes manually. and apply the changes manually and then answer. Yeah, you can revert the changes to ask with commit. Again, you can do it using the, as I show you once, by pressing right click on file, then replace with, and you can previously you can choose previous local history. And also can be done. You can use commands as well if you want. Start with file comparison example, and that's just the one I showed you. Yeah, project hosting, that's the last point on this topic. So again, we use Bitbucket, but again there are so many different hosting sites because basically our changes need to be located somewhere. Yeah, it is not just possible to put them somewhere in cloud and hope that they can be stored somewhere. Somewhere there. Everything needs to be stored somewhere, and for this purpose we use hosting sites again, as all the websites, all the stuff, most of the stuff are located on the hosting sites. And yes, there are different popular hosting sites, and GitHub and those who tried to do some development may already heard about it. Maybe the most popular in the world. And so many projects are stored there. Yeah, so many. It's also free. So many things are located in GitHub. There's also Git Lab. Just if you don't like GitHub, you can use Git Lab. Same feature. Okay, maybe we can open them. Okay, let me see. And GitHub, maybe you already seen this cat, this logo. That's GitHub. The functionality is quite the same as we have in Bitbucket. And I think you may also seen this logo, this fox. I hope this is fox. Also quite similar to GitHub, and it's also free. Then SourceForge, I didn't use this. It's open source for projects only. I understand. Yeah, Bitbucket, the one we just currently use. Why I like Bitbucket? Because it has the integration with free key features. Not only these free, but I can. Okay, I think there's no list of all the related. It shows me the dashboard, but okay, never mind. Yeah, it is integrated with Jira, as we already as we already seen, and it is integrated with source tree. Source tree, that's quite similar to Eclipse or IntelliJ. If you use it's, to be honest, that's from my point of view is more easier to use than Eclipse. It's easier to use than Eclipse. It has some nice integrations with Bitbucket and Jira, so it's easier to use it in most cases. But yeah, that's why we use Bitbucket, and why I like Bitbucket more than, because it has such same integration with SourceTree and Jira. Yeah, we don't use SourceTree, we use Eclipse, but it's also fine in our case. And that's why Bitbucket. And you can also find some other online repositories. There are so many different hosting sites available. Okay, that's pretty it about version control. Yeah, I think on Monday we will have in Eclipse we have this task. That's activity 18, I think. That won't be homework for you, because again I want you to go with your projects. But we will do it together in class on Monday. To be honest, I haven't taken a look on this exercise yet, so I will prepare we'll do it on Monday. We'll just go through it together. So I think the description needs to be here, Okay, I will check it on Monday, but it's easy to do here as well. Okay, so here's my, but yeah, we'll check it on Monday. Check it on Monday. At the moment, I want to finish with the presentations we have, and then I will finish with version control. Yeah, we will, as usual, have the question and answer session today after just kind of after the break. We'll have a little bit later, but for now let's start with software development project. You already started working on the project, but now let's talk about some key things on the software project, on some approaches used, on some techniques used in projects, and maybe it may not be quite clear what the project is. what basically is the project, and it's a software development project. It's not kind of the same as the projects you may have in different areas. I mean, not in the IT, in this kind of projects you have in schools, universities, or something like that. It's not the same. Yeah, it's not just like you come together, do some stuff, then you present the stuff, and until you forget about it. Yeah. As it usually happens, at least in my experience in school and in high school, how it happened. In software development, it's much more important. To be honest, since I have not worked in other areas, but information technologies, I cannot really talk about how it happens there. Maybe there are some similarities, maybe not. I don't know, to be honest. That's why maybe I won't say that there's something, not something, but everything is different from the techniques used in other not software projects. But again, the main idea now we're talking about the business, because in every IT software development project, the main purpose that's the business, just this is the part of the business, and of course in every business the main idea is to get profit. And again, if we talk about the software development project, again, the main target, the main purpose of the projects are to for those who do development, for the team, for that company, and just in most cases, like in Accenture case, and for other companies who provide IT solutions, it's again, the idea is there's the customer. So the idea is there's the customer. So there's the customer. Just every company. In most cases, for Accenture, for those who work with Accenture or other IT companies, that should be a huge company, a company with a huge budget. So it's because IT projects are quite expensive. So that's the company. The company needs the IT solution. Then this company calls, for example, an Accenture or other company. In the world, there are so many companies in the world. And then this client, so this is the client. We call this company as the client. So the client requires solution from the IT company, like Accenture, and maybe other company, just really matter. And so this company cooperates together. Now they are cooperating to provide the IT solution for this company. So this is client, and this is the company which provides the IT solution, maybe let's call it provider. In theory, what can also be done here, there may be different companies as well. In most usual cases, there are not too much companies, but in huge projects there are, that's also provider, but in huge projects, at least in my experience, there should be 2 or 3 companies which are who provide the solutions, and of course in most cases they should also cooperate together. Yeah. So in this case we have such chain. And in most cases, this sometimes maybe some chains are not here. Maybe this one, for example, this can be done this way. If the topics they are working on are absolutely different, yeah. But again, some linkages maybe between these companies, and of course they all should have a linkage with the clients. Yeah. And yes, that's how the main design works. And of course, money comes from simply money come from here. Then they pay for the development these companies provide. Again, remember that the budget in most cases is limited. Yeah. That's why we have some limitations here. It's not like the projects are just simply given to us and we can do whatever we want. Yeah. The time is limited, the budget is limited, and the requirements may, like in some cases, requirements may seem to be unlimited, but requirements are also limited. Yeah, in fact, we may consider them as limited, but requirements are also limited. So everything is limited, and yeah. And again, this is not like in school or in high school when you just come, do something, and finish it. Yeah. There are so many different types of life cycles. So, for my point of view, most of them are quite similar. These life cycles, yeah, which may be applied to the projects, but they have some differences, and in general we will talk about them. Yeah, and as I already mentioned, let's maybe start with what we don't manage in our project management. It's not like we just it's not like the project is just with the requirement. Yeah, the client provides us the requirement, and we just write the code, we give this code, and go away. Yeah, it doesn't work. Yeah, so just simply write down code that does not work. Yeah, also it is not like we code and fix with cowboy coding, hacking, and all this stuff. I don't use that for funny, so again, it doesn't work in this way. It doesn't work in the way that the client gives us the requirement. So, for example, the client asks us to please create me the website. It doesn't work in the way that client gives us the list of the requirements. Then we create this website and give it to client and go away or provide some support. It doesn't work like this. But again, you may ask, how does it actually work? We'll talk about it. But yeah, just please don't think that this is as simple as just coding. Of course, there should be the planning, the resource planning. Again, also the resources are limited, number of developers are limited, and yeah, the huge problem is for many IT projects that there are a few developers only. There are a few developers, and it is not, in some cases, it is not really possible to finish something in time, or to manage to do a lot of things at the same time. That's why please, just also note this one as well. This model starts with an informal general product ID and just developers call until the product is ready. Again, also does not work as well. Just fork is in a random order. That's also not does not work. They are so-called solo projects, but this is a little bit different. We will don't include this topic in our case. This thing works in your solo projects. Like for me, what I'm currently doing, I'm trying to create a website, and working on my website, and that's the sole project. So I don't have the client, I don't have some maybe colleagues, but partners who with whom I collaborate. So that's the sole project, and of course for this case I can do whatever I want. I don't have the budget, I don't have the time limit. No, actually I do have a little bit, but just not as strict as maybe in the huge collaborative project. So we are not. So we want to include these scenarios in our topic. We will only talk about non-trivial collaborative software development projects as it stands here, where there is it's also not really correct if I say a huge team. In fact, the team may be not so huge in some cases, but maybe kind of at least 5+ people that may be considered as a team for collaborative software development project. In some cases it should not be, usually it should not be less than 5 people team, even for small projects. But again, I think I understand the difference between solo and collaborative software projects. So we'll talk about collaborative projects only. And again, let's start with the problems. Why do we need this software development project management? Just to remember all these chain of words. And software development project management. Or just let's call it project management. Not remember all these 4 words. Project management. So why do we need project management? Why do we need project management? That's imagine we have, I think you all maybe seen this when you just when you drive somewhere and you see that the workers repair the roads, and in some cases only there is kind of the task they need to do, and only one of them works and others just stay and not doing anything. That's also the key, maybe not. That's called the key. The key thing. Why do we need the project management? There are also different reasons, but this is maybe the most obvious reasons. Again, we have resources. These are the resources, and we have the goals. The goal is just to repair this traffic lights. So again we can see there's the issue that something is not correct here. And to manage it, we need to have the project management. And there is so-called Brooks law. Yeah. Adding manpower to a late software project makes it later. That's also true, because as you may remember, I just mentioned that sometimes there is a huge problem with the resources on the project, that there are a few people available to do some things, and that may be the problem. But that's on one side. On the other hand, if we have too much manpower on the project, that may also raise some chaos. Yeah? Just example from our experience, in the project I worked, there were, as I think I mentioned it once, at least once, there were 300 colleagues, developers, let's call them. It's not only developers, but the participants of this project, let's call them colleagues, participants of this project, were included from 4 different companies. Yeah, there were 4 different companies, 3 foreign companies and 1 just the client. Yeah, also some people from the client were also working on this project, and the main issue was that there were too many people. Just one do one stuff, and another developer do different stuff. In fact, the requirements are different. For the same things, the requirements may be different. There is absolutely no linkage between these two developments, and at the end, when everything is mixed, nothing works. Yeah, or as it was in most general case, something is broken. Yeah, then so there's the bug, the dump, or something like that. Something is broken, something does not work. So developer A comes, let's call it developer 1. Yeah, developer 1 comes, fix this bug. This issue is fixed. Just one representative of the client is happy that the issue is fixed. Then after in 2 weeks, the client representative 2 comes and says that to different developer and says that they found another issue. Then this developer, and in fact this issue is related to the previous fix applied by the first developer. Yeah. So in fact something is fixed, then different things are broken, and this is just like an endless cycle. That's why the project was unsuccessful, and as it stands from the news, they lost 100 million euros on this project. Yeah, in the end, sounds like nightmare. Yes, that may happen if there is not good project management. And in the end, the client just that's a lot of money, but in fact it's that's not the record. Yeah, when the solution, when 100 millions of euros, that's not the record. As I read from newspapers, Widow. Yeah, I think everyone knows what Widow is. They lost one time. They lost 500 millions and they lost 500 millions of euros. I think I can. So that's the public information. So they were. That you can only if you type Widow SIP. If I think maybe you know what SIP means, Service Application Products. That's basically the products I'm working with. This is just the business, the software for the businesses. And you can already see that if you type Widow SIP, one of the searches goes from here to this one. Widow lost 5 millions. 5 millions. And that's the public information. Let's see. That's not the client I was working with. The different client. Maybe I won't show you the client I was working with, but I'm just saying that this that also was the public information that they lost 100 millions of euros. So again, that's also the example that some software development projects may fail, but that's also it is also possible. I'm not sure what happened in Widow. I was not working with them, but yes, they lost a lot of money. You can. I'm not sure who was the provider. Actually, Accenture was the one who helped Widow to roll out. As it stands from here. So I'm not involved in this, but Accenture was hired to assist to roll out. It is also needed to roll out for the projects, because it's not like you just try to create your solution, that's also a very huge system built. So there is. I just want to have it like anti-advertisement of the development. But Accenture was not the ones, as I see from this newspaper, who failed this project. Accenture, it stems from this news that from this post that Accenture just helped to roll out. So it's not, Accenture is not the ones who failed this project. But again, the idea is that it's not just as simple that you create the solution and then you understand that it does not work. You cannot just simply leave it as is and just say, we don't need it, just keep it as is, and starting tomorrow we will do different things. It's also not possible, as that stands from this article that there also rollback needs to be done, even if the project is failed. Yes, that's how it should be done. So the rollback is also the very important part, because of lots of different things. If the system is built, some information is provided, then it is also really important to have the right rollback of all the changes done. So yeah, sometimes yeah, I need to make more money. Yeah, most likely, but again, not every project may be successful. That stands. And in most cases, that happens because of the project management. That the project management is not really good. And it may be from the client point, it may be from the developer's point, miscommunication between the teams. As we have from my experience, as I had, there was huge miscommunication between the teams. Actually, there were, as I said, there were 3 companies work for the client, and also there were representatives from the client. And that's why we had to communicate with the client. We had to communicate with other representatives. With the client. I missed one really important point. At least what I faced in the project, which, in my experience, which failed. There are also different vendors or suppliers. And even more, there may be tens and maybe hundreds of them. Just then suppliers for the clients, and they are also. This is also a really important part of the project, because we had to also to communicate with the suppliers. So the client has the business, right? They have some services from many different resources. And what we need to do for the software development, for the development, we need to integrate all the stuff just basically to satisfy all the suppliers, all the vendors, for the client. Like if this is just imagine, just simple example, if we take any global corporation, like maybe Apple or McDonald's, maybe let's talk about McDonald's or any food, fast food restaurants or any restaurants. Imagine that the client is the restaurant. That's the restaurant. Just imagine any chains of restaurants. Maybe McDonald's. Let's stay with McDonald's. McDonald's. So McDonald's have different. They have different suppliers. Suppliers for potatoes, for sauces, and so on and so on. For drinks, there are so many different suppliers. And imagine that you need to build a software solution for the clients. And in this case, we need to consider that that these suppliers may have different patterns, how they send the information, or how they do their processes. So this may be different for different suppliers. And in this case, we also need to communicate with these suppliers. So imagine that all these chains, all these connections need to be managed. And in our project I was working with that was not done. But normally, again, projects are maybe quite complicated, and that's why you should always think about that this stuff needs to be managed in some way. Yes, that's how it is. Okay, maybe let's finish with this slide. There's something more, and yeah, if you have more manpower than you need, then in fact that may even make the things worse, because yeah, they may just interfere with each other's. Again, as I said, if the issues occur in different places and the issues are related, we need to establish the correct communication between all these developers, and that may be quite difficult in some cases, and if it is not achieved, then we'll see even more issues with the code, with the logic, with the development done. Yeah. So please, you should understand that it's not like if we add more manpower, then we make it faster. Imagine the same if you just, in a simple example, if you want to build a house, try to build a house, then if you add just like imagine you want to build a house in a day, for example, normal house, not just the one which can be built from different components, but just a simple normal house. Again, if you invite hundreds or thousands of workers, that won't be quite possible to achieve it. And if you just simply add 10 workers more to the building of your house, that won't work. All the workers need to be managed correctly, need to understand what to do, and need to cooperate with each other. Only in this case you may have the result. But what did TOA software project? So in this case it means that the project is late, so you need to finish all the things faster, and if you at the ending point, if you add more people, these people usually don't know the stuff done before, so not what the stuff is done before, how the stuff works, and they don't know how to proceed with the changes. So they need to be everything still needs to be managed correctly. That's why it's not as easy as it may be, as you may think. Okay, and it takes some time for the people added to a project to become productive. That's what I'm saying. It's practically impossible to just simply add the person and get the result. Always need to integrate this person into the project, and it may need to take some time. It may take some time. Yes, as more people work on the project, it is harder to split up the tasks in parallel and dependent streams. That's what you can see here. and to mention that on all these let's call them all these points, there are like hundreds of people, yeah, maybe tens or hundreds of people, and imagine that at the result we'll have kind of 500 people, and imagine that we need to connect all of them, yeah. That may be quite complicated, yeah? So if there are more people, it's harder to split up tasks in parallel. Then communication management, yeah, that's some approximation of time, and how it usually works. Yeah, if we add n people to the project, then n square, yeah, number of people to the projects, then we can only raise the productivity not higher than the n before. The opposite way, if we just add n people, then we can just take the square root of n people. Yeah. It's kind of the same formula, really. But that's just the approximation and how to make BootCamp. Strict configuration management is necessary to avoid it works in my machine issues. Just again, imagine if we have the same system for all these departments, and just if one department works, and they try to. There may be some conflicts between the departments, so that's also needs to be configured correctly to avoid these conflicts. Right? Okay, let's have the break now, and after the break, let's have the questions and answer session. Okay, let's move to our questions and answers session. Yeah, are there any questions specifically? Have you managed to have any progress on your on the project or the teams? Just can each team update, please? Just how it is going? Is there have you started already or not? And those. Is there starting? I mean, you can, yes, you need to create database in the localhost, yeah. I'm not really sure what you mean by Java code for that. I think you just simply create database, then you need to add new entries from and update new entries from Java code, yeah. Yes, Svetlana. Need to create. Then I'm not really sure what you mean by create localhost connection to localhost in each branch, because at the end you should have only. I mean, this code needs to be in all the in the final solution. Yeah. So again, in the branches you just have the copies of the main branch, and the connection to the localhost should be the same in all the branches. I mean, it should be in all the branches. I think just for the testing purposes you can create it by yourselves. For the files, yeah, I will also add some testing from my side, but in general I think you can create the files by your own. Regarding XML and JSON files, you should just have one main object, yeah, as we were talking, and under this main object you'll have different entries, yeah, different items. So if it's JSON, that's the array. You should have the main object, then you have the array of the entries, and each entry needs to be represented in the database. Yeah? Question from Marta: we should not add data in database, and should it? It doesn't really matter. Yeah, if it's empty at the beginning, for the final presentation, you just it should not mandatorily be empty. Yeah, just in case it is not empty, so you should be able to add new entries to this table. Yeah. So just for you to be able to present it at the end. Yeah. That's. I will try to provide some test files for you, and hopefully next week. Hope I will have the time. Okay. Yeah, for Win, okay, maybe we can have a discussion tomorrow about it. Yeah, sure. How to use Jira? Yes. Again, Jira is needed to split, to reflect how you split the work with each others, and how you yeah, not only with each others, but in all the project. Yeah. So the idea is that you have to have the tasks, yeah, for like the tasks as checkpoints in most cases. And what I want to see how you deal with Jira, that for each task you create the ticket in Jira, then you move this ticket from to do, then in progress, then it is done. Yeah? So there's just 3 stages. In practical life there may be more than 3 stages. Like in this case we just have to do in progress and done. Sometimes there'll be some additional stages there, but for our case it's enough that we have 3 stages. So again, you need to create tickets for it's up to you how you split it, just to make it as much representative as you can do it. So that's how you need to use Jira. But yeah, certainly maybe you ask it in a more general way. We will how it is usually used. We will talk about some different life cycles of the projects, and in this cycles we will see how Jira can be used. But for this project, for the project you are working on, that's just for tickets mostly. Okay, question from Zana. We add data in the tables, then each of the file read the table, and then upload the file. You create, first of all you just need to create one table. So I don't ask you to create more than one table, so just one table you create. Then using Java code we need to transfer the data from the files. Again, 3 types of files: CSV, then JSON and XML. You parse these files in your Java code. Then after that the database needs to be updated. So that's the idea. At the end, I just want to see all the data to be transferred to the database. And as the second part, also some data needs to be fetched from the database based on the parameters provided. From previous time, if we have database fields, currency. What is the currency of the country? So the key field is country. then that's the what is the currency in this particular country used. Yeah. Is it that small, really? Sorry, that's my mistype. Yeah. I'm so sorry. Yeah, I'm sorry. That was my mistype. It should not be that small. Yeah. I'm sorry. I just. Yeah. Yes, that should be the text. Yeah. I'm sorry. Yeah. I'm sorry. I'm just. You just mix it up. Sorry. Yeah. It should be text. Yeah. And that's small. For Marita, we create database table, yeah, that's correct. Create files, write Java code for reading, writing those files, and to database, yeah. Yes, that's correct, yeah. And what I want to see meaningful structure of the code, yeah. So everything is put correctly, not just like you put everything in kind of main method, then so without object-oriented programming. So try to use as much approaches as we were learning about. And again, please don't forget about the Excel, well, not Excel, but spread, about the sheet file I shared with you. Oh, yeah, it's very good. There are some topics, yeah. There are some topics, and yeah, and in case just don't forget, I'll share it again, don't forget about this spreadsheet. We'll talk as much as possible next week about it. Is it possible to use abstract classes for yes, Svetlana, yes, it's highly recommended to use abstract classes. Why? Because and maybe just again we have just so we may have something in common between, imagine just like we have 3 classes, yeah, maybe, yeah, not talking about the solution you will create, but that you select to work on, but just as an example, we may have 3 different classes. So this class is for CSV, this class is for XML, and this class is for JSON. So they all may have something in common, yeah. Some similar methods, maybe some similar methods, maybe some constructors may be similar. So in this case, you may have an abstract class which not unifies but implements the common things, or defines, yeah, if we define abstract methods. So in this class we may define some abstract methods which may be different in all these classes, where we can use, or for some common things we may use the implemented methods. So it is highly recommended, and it is possible, yeah, of course it's possible to use abstract class here. Marit, should those Jira tickets be very detailed? You mean with the putting descriptions? And to be honest, no, that should not be really detailed, at least from real life. How it usually happens that the ticket just points to some things. Again, it depends on the project, but I think in our case Jira tasks should not be very detailed. Yeah. In the real life, again, it depends on the project where it is. Some projects, if there are lots of tickets, then they are not usually described in very details. In details, if there are a few tickets with a huge developments in each ticket to be done, then they may be described in details, yeah. But in your case, they should not be very detailed. Yeah. Okay, so this is your first project. That would be fine if you just understand the concept of the tickets and use them for your development. For the book publishing, here we should use date. This is one number. Yes, we should use date. Small number, maybe let's check about